Hello everyone, welcome back to the workshop. This video is measurement and correction of Endfloat on the crankshaft of the BSA Bantam. I'm going to start off on the lathe. I'm going to make a piece which I require to do the job, a little bit of tooling, and then we'll get into the job proper. As you can see, the Bantam is telling you that you need to be somewhere else. I hope that you stick around long enough to watch the video before you disappear off to the pub. So without further ado, let's get into the job. I know some people like to see great big lumps of swarf coming off. Can't blame you. It works for me. And that's why I'm filming this bit. I'm just making a quill to the end of the crankshaft, just a little protective cap almost. And all will become apparent. I just thought I'd give you the opportunity to see some nice big stringy Terry Castles, as my brother and I used to call them when we were little, when we were peeling off wallpaper. We were meant to be peeling it off, it's the decorating. Anyway, that's what we call them. There's a story behind it. For another time. Right, so we're parting it off. See how we get on with that. It's only a 2000 series aluminium alloy, so we shouldn't run into any problems, hopefully. Quite a nice parting tool this, it's kind of metal. It's quite a nice one. Doing. Get out. There we go. Let's just finish that. Finish that end off. Little chamfer, and I think we'll put a centre drill in it just to help it on its way. All will become apparent. I keep saying that, don't I? I promise it will. It's method behind the considerable madness. Chamfering tool. That'll do. Nope, we locked the carriage, didn't we? Because we're parting. Helps if you unlock the carriage. It moves then. Don't be alarmed, it's my incompetence. Right. Just break the edges. That'll do. Make a good job of it where we can. Right, I'll flip that round, break the edge on the other end, and that's it done. You join me back at the bench where you can see that the crankshaft has been fitted into the crankcases and secured by 2 bolts, one here and one here, in line with the BSA Service Sheet 506. The purpose of doing this is to measure the end float of the crankshaft, i.e. the lateral movement in the bearings. We're aiming for a figure of between 4 and 6 thousandths, which is correctable with shims, which I have some shims. I have a pack of shims. So the aim of this exercise is to measure the total end float and then determine what shims we need to set the figure to the value advised by BSA in the service sheet. So this is the quill that I was making on the lathe. As you can see, it's been bored out to fit over the timing side shaft, and there's a counter bore at the very end of the, you can't see it, it's at that end, the very end of the piece, to accept the diameter which is provided for the ignition points cam, and the purpose of that is to protect the end of the crankshaft, because we're going to be putting some force onto this end of the crankshaft in order to move it laterally through the bearings and measure the end float on the other end using a dial gauge. The service sheet doesn't actually give you a method for measuring this this end float. It just tells you to do it. Now, you'll appreciate that these machines were exported to a worldwide market. Excuse me. And I imagine that BSA, you know, they just expected you to come up with a method that suited the tools and equipment that you had in your place of work. I've read quite a bit about doing this job, and there's probably as many methods as there are people doing it. A lot of people use feeler gauges between the end of the crank web in here and the bearing, but yeah, you know, it's a good method. Feeler gauges are precision measuring equipment, but it seemed a fairly haphazard operation to me. It seemed quite tricky and difficult to get repeatable results. And then the other method that I've read about is basically you pack out one side of the crankshaft inside between the bearing and the crank journal to achieve a gap here in the crankcase halves. So you basically pack it out until you do get a gap. You then measure that gap. You subtract the size of the packer that you used from that measurement, and that gives you your end float. Again, it seemed to me, I'm sure it works. I'm sure that a lot of people have used it and got good results, but to me, I kind of I debated whether or not you could control the size of that gap accurately simply by, you know, putting longer bolts in and tightening them up. It occurred to me that if you over tighten the bolts, you could actually deform the crankcase and end up with a couple of thousandths difference. So I decided to use a dial gauge, which is what we're going to do here. Now, you can see that there's these pieces of aluminium that I've bolted, drilled 2 holes in each one at the correct spacing for casing screws, and I've bolted them to the timing side of the crankcase. And you've seen these before. I used them actually as spacers when I was pressing the crank together. They're handy bits of scrap metal. And the reason why I've bolted these on here is because I intend to use my universal bearing puller to exert force on the crankshaft. And this is just a universal, fairly inexpensive kit. You can get them at most sort of tool factors, Machine Mart, places like that, Halfords. I think over in the States, I think it's Harbour Freight is a kind of equivalent sort of place. I'm sure you'll be able to find one fairly cheap. And so instead of using it as a puller, I'm going to use it as a pusher, and it engages with these two bits of scrap aluminium. Obviously they're not going to move because they're bolted to the casing. When we tighten the lead screw, the crank is going to move towards the drive side, the primary side. I'm just going to go handheld to show you the rest of the setup. Please bear with me. You'll notice that there is a socket extension through the small end, and that's to guard against any rotation of the crank. We don't want the crank to turn as we're moving it through the bearings, because on the other side we have a dial gauge. I hope there's enough light. A dial gauge bearing against the primary sprocket. Now I've just fitted the primary sprocket temporarily to provide a nice flat surface for the DTI, and we'll move around the other side. You can see how I fitted the clock. I was lucky enough to find that one of the adapters in my DTI kit had a BSF thread on the end of it, and that just happened to be the right thread for a Bantam crankcase. So that's threaded into one of the primary cover casing screws, and then the clock is mounted with an adapter onto there and is bearing against the primary sprocket. And then the reason why I wanted to lock the crank was because any deviation in the surface of the primary sprocket, it's not necessarily a perfectly flat item because it doesn't need to be. Any sort of cam effect that this might have would give us a false reading. We want a linear motion of the crankshaft moving in a positive direction. We don't want any rotation, because that obviously could give us that cam effect and could add add extra positive reading to the clock. So that's how I'm going to do it. I'm going to force the crank through the bearings this way, and then we're going to measure the positive reading on the clock, and then from that we'll use that that data to calculate the shims. And according to the service sheet, which unfortunately, we'll just put you back in the stand. Unfortunately, the service sheet only goes up to the D5 model, and this is a D7 model. I'm not entirely sure if they updated that at all. I don't think they did. But they say that all models with an engine number beginning ED5, you should only shim on the timing side. Now this is an ED7, but I have noticed actually that with the crankshaft fully towards the timing side, the rod is off center ever so slightly, and it wants to go in that direction. So I actually think that the data for the D5 is the same for the D7, and that we'll be shimming on the timing side in order to move the rod towards the central position as we correct the end flow. And I spoke with, or I corresponded with Bones at Oz Bantams, and if you're going to ask somebody a question about how to build a Bantam engine, he's the man to ask. And he basically said, well, the way I do it is I shim them so that the rod is central. And so yeah, I think, you know, it's nice to get corroborating data. So the service sheet is telling us to put a shim in the timing side. The rod does appear to want to move towards the drive side, and Bones has built lots of engines and has always shimmed them to get the rod central and not had a problem. So I think those two bits of information marry up, and we're definitely heading in the right direction. So I'll stop waffling and we'll crank the thing over and see if we can measure the end flow. And we're in focus, needle on 0, and winding the screw. 19.5 thousandths. And checking for focus. Yep, we're in focus, and we're on 0. And that's as far as I want to go. And we've got, yeah, just a shade under 19.5 thousandths. So I think we can say that seems to have worked with consistent readings. So 19.5 thousandths without any shims at all. Well, that's the crankcase halves separated to expose the crankshaft and ready for the shims. I was able to use the puller to draw the crankcase half off of the crankshaft once I'd removed the crankcase screws. So dual purpose tooling, we like that. Let's put that down. And you recall we had 19.5 or thereabouts. That half thou was a little bit ambiguous. It could have been a little bit of flex that we were getting. But in any case, if we put 15 thou of shims, that's a 10 and a 5. That should bring us down to minimum 4, maximum 4.5. Which is right on the lower end of the specifications for the Endfloat. So that's good. So we'll put those on there. I'll put a little bit of oil on the journal ready for the bearing, and I'll get the crankcase half back together and we'll have another measure. Right, so we're back together, and let's see if we can get that value that we were looking for. The puller's come off. That doesn't help, does it? Well, that's about as tight as I want to go. And if you're seeing that, I make that a shade over 4 thousandths, not quite 4.5. So quite happy with that. Let's have another go. Right, back to 0. One more go for the sake of repeatability. Oh, puller's pulled off, but I got 4 thousandths. So between 4.5 before the puller slipped off. Yeah, I think we've proved that. I think it works, and I'm more than happy with the result. Well, I think that's it for this video. We set out to measure and correct the Endfloat on the Bantam crankshaft, and I think that's exactly what we've done. We've achieved the figures that the BSA Service Sheet was looking for, so I'm very happy with how that turned out. The next video on the BSA at least will be reassembling the gearbox. I'm just waiting for a couple of bits and pieces to come in, so that will be the next BSA video. I'm also looking at renewing the bearings in the headstock of the lathe, so I'm going to make a video regarding that at some point in the near future. And then I've got another little project, which is another bike. Not the Bantam this time, which I think is a recommissioning job, and I think that a few of you will find that interesting. A little bit of nostalgia for some of you out there, I think. So that's to come. This video, as I say with all my videos, it's not a definitive how-to. This is how I managed to get this job done in my workshop with the tools and equipment available to me. and there are other methods out there, and I'm sure that guys have a lot of success with those other methods. This is how I've done it. If you can cobble together the same setup that I have, you can do it. You can get the same results. I've learned a lot. I hope that you have, and I've really enjoyed making the video. I'd just like to take this opportunity to recommend another channel, brand new channel, and it's my brother actually, and we're going to go over the high-tech notepad. Carl Wilson, that's the name of the channel, and that is also his name. He's just started out. He's got a couple of videos out there. They're really good. I do recommend them. If you're at all interested in a little bit of the theory behind what we do in our home workshops, then definitely go take a look. He's recently been renewing the scales on his DRO and figuring out the pinouts, the plug connections using an oscilloscope. He's been messing around with his compressor. I think he had to change the relief valve, and so he does a little bit on the theory of how the relief valve works and how to set it up. And it's all very manageable, easy to understand stuff, but it just takes you that little bit further than just prattling around with spanners. It actually takes you into the how it works and why it works, and I think you'll find it very interesting. I'll leave a link in my description. I'd appreciate it if you'd check him out. I hope you've all had a good Christmas, and I wish you all the very best for 2022. I hope it's a little bit easier than the last couple of years, but I'm sure we'll get through. We got through the last two, so I'm sure we can cope with anything that gets thrown at us. But all the very best. Thank you to subscribers. I picked up a couple of new subscribers over Christmas, so thank you and welcome. And to all my subscribers and my fellow YouTube creators who offer me lots of support, thank you very much. If you like what you see, you like what I'm doing, please click the like button. Please give me a subscription. It makes all the difference. So until the next video, thanks very much. Take care of yourselves.